Here in this part, can you see this structure that looks like a snail? That's called the cochlea or the cochlea. You can say it either way. Now, if I take that cochlea right there, here, can you recognize it right here? Blow it up, and I look at the inside of it, this is what it looks like right here. Because we're going to talk about how there are two parts to the cochlea. There's this outer part right here that's made up of bone, and then there's this inner part right here that we're going to call the membranous labyrinth. The bone part we're going to call the bony labyrinth. The inside part we're going to call the membranous labyrinth or the scala media. Okay? Now, going back to that again, when you think about the cochlea, what I want you to think about is a pipe within a pipe. Can everybody imagine a white PVC pipe? A big white PVC pipe. Can everyone picture that in their mind? Okay. Now can you imagine a garden hose? That I put a garden hose inside of that PVC pipe. And then I start to twist it. That's what the cochlea is like. The PVC pipe is bone. It's bone, hollow bone. And then stuck inside of it, the garden hose would be this membranous labyrinth. So again, we have a pipe within a pipe, twisted in around. This is what it looks like if we take just one little section. Can you see bone? Pink bone. Here we have the bone. Here's that middle part, and then bone. Now, again, imagine it going around in 3D. And notice we have these repeating structures here. Those repeating structures that I've also put those squares around right here, those are the structures that have the receptors for hearing. They have the receptor for hearing. They're called hair cells. And so if we blow those up, we can see those hair cells. I'm going to blow them up a little. Here they are right here. Can you see these cells right here?
Yes.
So when sound waves come, there's fluid inside of here. And those sound waves are going to move this membrane, these cells right here. And these cells are attached to this membrane that's like a roof. In Spanish, we use the word techo, right, for roof. It's called not the techo, but the tectorial membrane, the tectorial. And it has this little loop here. I call it the loop-de-loop right here. It's just this little loop-de-loop that's really cute and that easily you can recognize it.
It looks like an ethical.
So this is the tectorial membrane. These right here are the sensory receptors. We're going to call them hair cells. And so when the fluid moves these hair cells, because they're attached to this roof, that then moves this basilar membrane, this membrane at the base. And that's then going to exit as a nerve right here that we're going to call the cochlear nerve. So again, identify these structures. Hair cells. These are the sensory neurons. Identify this structure. Tectorial membrane. Identify this structure. Basilar membrane. And these right here are axons that exit as the
Nerve.
Cochlear nerve. We're in the ear. So all of these right here. Here's the axons that are going to come out this way and exit as the optic, cochlear nerve. Okay. Here's another view of it. Identify these structures. Hair cells. I'm sorry, I don't know why this keeps going. Oh, because it's shown as a slideshow. That's cool. And this one right here.
The tectorial membrane.
Tectorial membrane right here. Basilar membrane. Can you see all these axons exiting as the
Cochlear nerve.
Cochlear nerve. Very good. Identify the structures.
Hair cells.
Hair cells.
Basilar nerve. Or tectorial.
Tectorial. There's the little loop-de-loop, and right there.
Basilar.
Basilar. Now, there's another membrane that comes across right here. That's called the vestibular membrane. And it divides up this area that we're going to call the scala vestibula from this area, which is called the scala media, or the cochlear duct. Again, can you see that scala, that's vestibular membrane?
Yes.
Okay, so here's the loop-de-loop, the tectorial, hair cells, and basilar membrane. So let's go.